Oh God, it is. I'm operating on con time.
We'll go with morning.
Yeah, I don't feel like I got up, 8 hours ago. Probably didn't, but welcome to Intermediate Electronics for Cosplayers. How to be the bomb, but not literally. Much like not setting yourself on fire, not killing the people around you, and not gassing yourself in such a cosplay. I'm Mark, or Sparky, as this thing tells me. No. Yeah, might as well. Thanks. I am an electronics engineer, been doing it about 10 years, work in medical research. I do this stuff a lot. I don't do cosplay so much, but I know my electronics. And hopefully soon you will too. We'll start with the basics. Oh, no, the basics were an hour and a half ago, but we'll go on to the basics I didn't cover in the basics. Capacitors. They're components, store electricity, mostly used for smoothing or cleaning up dirty signals. I'm mentioning them mostly because you will find them in other projects, often just to... They'll be attached on either side of a project to clean up spikes, power surges, things like that. Very important. You can sometimes leave them out. You'll see a diagram online for a component, and it'll have, or a system, and it'll have a couple of little capacitors at the beginning and the end to clean up the signal, to prevent spikes from causing damage. You don't always have to have them in there, but it's recommended, just because otherwise you'll end up with a dirty electricity supply, and you can end up with unexpected effects. Lots of different flavours, electrolytic, tantalum, things like that. If you're dealing with electrolytic, they are polarised. They will only go into a circuit one way round. They'll usually have negative symbols on the negative leg. If you put those in backwards, they will explode. It's not a big explosion, but if you got your face right up against the circuit, you could end up with something nasty in your eye, so do it at arm's length. And then, give it a couple of seconds before you step too close. Capacitors measured in farads. You usually won't deal with anything over a couple of hundred microfarads, but if you look at, I don't know if anyone's ever looked at car stereo systems, the big banging ones. They'll have like 1 farad capacitors in there. Those things look like milk bottles, and they are, from a capacitor point of view, they're massive. Yeah, you'll get bigger ones if you go to power stations, but why the hell are people putting them in cars? I know, they have their purpose, but that's just, so if anyone says capacitors, you kind of know what they're talking about. They come all different sorts. The ones down the bottom, the black ones, the little bottle-shaped ones, they're electrolytics. Have to go in the right way around. I know I said the negative leg usually has little negative symbols on it. I have seen ones that have positive symbols on the positive leg, so don't assume. You get them around the wrong way. You've built your nice little circuit, you've powered it all up, you put it in your cosplay, then you test it with voltage. The pop comes along, and it's so annoying because you have to tear the whole thing down to get the parts out to read what. The smaller ones, the non-electrolytics, they're usually only in the nanofarad range. They're usually used for cleaning up signals approaching components, like I'll get to in a minute. They're non-polarised. You can put them in any way around you want. You can kill them with enough juice, but in general, it doesn't matter. Okay, this is the first bit of the real electronics that you might want to use for cosplays. Voltage regulation. Usually when you get a supply for any project, whatever, you'll run it off some sort of power supply, usually batteries in this case. For cosplay, usually batteries. You'll have a battery pack of, let's call it 6 volts to start off with, 4 AA batteries, nice standard, that gives you 6 volts. If your components need precisely 5 volts, that's a problem. You've got to get rid of that extra volt somewhere. Voltage regulators are generally what people use. You'll find them on the inputs to a lot of things. Any little electrical devices you've got, MP3 players, CD players, speakers, if you plug them in on the mains, they will generally have a voltage regulator on the input. What voltage regulators do is this particular sort of voltage regulator, they just throw away the excess power. If you've got 5 volts and you're drawing, let's say 100 milliamps, you've got 6 volts, you need 5 volts, you're drawing 100 milliamps to run a few LEDs. it's going to take that 100 milliamps at 5 volts extra, on 1 volt extra on top. You've got 5 volts. You want 5 volts. Let's say this back to the beginning, start again. Blah, blah, blah. You've got 6 volts. You're running at 100 milliamps. You want 5 volts at 100 milliamps. The regulator will just throw away that extra 1 volt at 100 milliamps. It'll turn it into 100 milliwatts of heat and dispose of it. As such, they usually come with mountings on that so you can mount heat sinks. They're useful, simple things. If you're only using 100 milliamps and you only want to drop a volt, very, very useful. It keeps you, it means you don't have to worry about, as your battery voltage drops over time, you don't have to worry about the voltage changing. You start at 6, it drops to 5, your components only ever see 5 volts. There are more complex ones called switched mode, DC to DC converters, charge pumps. These can step voltages up as well as down. You've got 3 volts, you need 10 volts. You put 3 volts in, you get 10 volts out. You sacrifice a bit of current, but you can have any voltage you want. If you're trying to get your electronics down as small as possible and you don't want massive battery packs, a charge pump can be incredibly useful. They can go the other way as well. You can start with 10 volts and take it down to 5 if you want. They're very, very efficient, so they don't get hot. The earlier sort of regulators, because they're throwing away the excess electricity as heat, they get hot. You need that heat sink, and if you're trying to put it in your hip or the back of your Cosplay, you're going to have something hot there. If you've put foam around it, you're going to find the foam melting if you generate too much heat. A charge pump or a regulator, you can, crank from 30 volts down to 3 volts if that's what you want, and there will be no excess heat. It's lovely from a perspective of getting your voltages right and being safe. Those are the 2 different sorts you've got. The ones over here are 7805 regulators. 3 pins, really simple. 7805, the 05 on the end means whatever voltage you put in, you get 5 volts out. There's a 7812 you can get that will give you 12 volts out. There's, I think, an 18, which will give you 18 volts out. You always have to have a higher voltage to start with. Say you put 24 volts in, you get 18 volts out, whatever you want. But it's a very simple way of going down. On the other side, you've got a buck converter, voltage pump, one of those circuits. It's much more, it's essentially a miniature circuit board all by itself. That takes in any voltage you care to throw at it and will spit out what the voltage it's designed to do or the voltage you set. You can sometimes put a little adjustment on it. I think that's got a little adjustable pot on there, this thing down here. You tweak it a little, the voltage goes up, goes down, you can get absolutely spot on the voltage on, even if it's unusual. And, as I say, very efficient, you don't waste energy. If you buy one of those first regulators, the simple ones, your component, the ground line is the central of the pin of the component, input there, output there. See the example here, 7.5 volts in, 5 volts out. Nice, crisp, clean. Whatever you run off that, you won't have to worry about your voltage levels. If you're only running a few LEDs, that's probably the one to choose, just because it's so much cheaper. The buck converters, things like that, I've actually used ones where it costs 20 quid for one converter, which if you're running a big project is fine, but if you're running something small, you want to be paying 50p for a regular voltage regulator. There's also one called the LM117, that's adjustable. You can just put, using that circuit there, put a little dialable potentiometer on there. It'll give you up to half an amp, and you can go from 32 volts input, anything from 1.4 upwards. Again, a great solution if you're trying to get a custom voltage and you don't want to build a complex battery chain to power your project. Transistor switching. Some of you probably run into this, some of you may not have. Basically, if you're driving an electronic output controller of some sort, quite often you'll only be using small voltages and small currents. Whatever is controlling your system may not have enough oomph to drive a light or a motor or something more complex. Transistors, they're like little switches. You put a signal in on one leg and it can control a much larger signal on the overall transistor. You can put 50 volts across the transistor, control it with a little 5-volt signal that's running, tiny, tiny signals. They're used as amplifiers in radio. We're using it in something called unity mode, or saturation. Basically it means either it's off or it's on. You feed a tiny signal in. But that's it. They're often used as amplifiers, but we're just using them as a switch in this case. There you go. You've got 12 volts across the transistor. You've got a transistor down here with its 3 legs, collector, base, and emitter. Collector just means the positive one, emitter is the negative one, or the one that power it out on. And the base is the little signal that comes in. That's where you put in your control signal. If you're running off a computer, say a parallel port on a PC, very useful for little projects, they can only supply about 20 milliamps. That's great if you want to run an LED, not so great if you want to run an entire motor. So you hook the motor up between the power line and the transistor, keep the transistor down to earth, and then you just send the digital signal from your computer or whatever in on your transistor base. It'll turn it on nicely. You always have to have more than 0.7 volts between the base and the emitter to turn the transistor on. Just it needs that much power to turn on by itself. The 2N2222, very common little transistor, wonderful for small projects. It'll take 30 odd volts. It's quite efficient. It won't generate a lot of heat, which is good because it doesn't have a heat sink on it. But it's quite hard to cook it if you're being sensible. Okay, pulse power. This is, actually, I built this the other day just as a demo piece. Most people think in terms of when you turn power on, you've got a component, you turn the power on, the power goes through it, it works. Reasonable enough. You don't have to have the power on all the time. When you're dealing with things like lights, you only have to have it on for a fraction of a second. Then you can turn it off, save the power, do something else. Your eye can't actually see what's going on. You can't see the sudden changes. It's the same with motors. And I don't know, anyone here remember the very, well, you're not going to remember, but the very first pocket calculators that came out back in the 70s, I think it was. Digital, yeah, we're going old school here. Little red LED display. The microchip they used in that, the Z80 chip, I think, it used a huge amount of power and they couldn't run it off a battery pack without having the battery pack 3 times the size of the calculator. Someone came up with a very good idea. Turn the power on and off very fast. You only have the chip powered 10% of the time, so it only uses 10% of the power, but there's enough power storage inside the chip that it only needs those little pulses of power. Battery extension and brightness and speed control, they're the main uses for it in Cosplay. What we're doing on that globe there, that is actually just 5 volts being turned on and off very fast. That's all it is. It's just how long it stays on for controls the brightness of the LEDs. You turn it on and off very fast, tiny short little pulses, the light's dim. You lengthen the pulse, the light gets brighter. Also, is anyone here at Ameshibi? Yeah? Did you go to the collecting vinyl figures panel? No? Okay. There was a chap there, he was worried about displaying his vinyl figures. He wanted to put LED lights in his display cases. But he was worried about the light damaging the vinyl, washing it out, making it age and crack. He did consider something like this. You turn the lights on and off very fast. That way you're only exposing the figures to light 50% of the time, maybe less than that. if to a normal person like you and I, it still looks like the light is always on, but the figures are only receiving 10% of the light. And more importantly for Cosplay, using 10% of the power. So you can say, a battery that would last you an hour, you run it like this, it runs 10 hours, or 5 depending on how the longer you run the pulses for, the more intense, the brighter the light you get, but uses more juice. So, that's a system called pulse width modulation. We'll go into that next. Yes. Basically, this is what I'm talking about. You've got an upper voltage and a lower voltage, usually 0 and 5 volts, and then you pulse the signal. The longer it's on, the higher the average voltage is. So you've got tiny little pulses, quite spread out, dark LED. You increase the length of the pulse, it gets brighter and brighter. It's all to do with persistence of vision in people. You can only see things that happen at, I think scientists say you can see things that happen at 120 hertz, 120 cycles per second. You run at 200 cycles per second, the human eye can't tell. So you can have lights, brightening, dimming, all that, and use a fraction of the power. Same thing for driving motors. If you've got a motor that is spinning like crazy and you don't want it spinning like crazy, use pulse power. Pulse modulation. You give it half the power, it's going to run half the speed. Turn it up and down, and the great thing is because it's just ons and offs, it's digital. Digital controllers can use that really easily. It's not a complex thing where you're trying to work out, oh, well, how do I build this circuit to give me 3.6 volts precisely when I press this button and then jump up to 8.2 volts later on. You just tell it, run at half speed. It works really well. See, this is basically the similar thing. This is, however, is using a composite LED. Basically, you've got 3 different color LEDs built into one housing. You've got 3 control lines and 1 ground, or 3 earth lines and 1 main, so VDD is ground. And then depending on the pulse frequency you feed in, you get different colors out, which is fantastic if you want a color changing LED. Really simple way to control it. I mean, that's not quite, I don't know if that's how they do it in TVs nowadays, rather than having 3 separate color LEDs where they use a mixed color one, but it's fantastic if you want a color changing effect in an outfit. It really works well. I was hoping to do it for this, but unfortunately I ran out of time. Arduino. I know you guys have, at least some of you have heard of it. It's a fantastic little mini computer. It's not as powerful as, I don't know, a Nintendo DS or something, but it's so easy to use, it's wonderful. You've got all those different signal pins that you can use, you've got all those different things you tie into, and they use virtually no power. I was running it the other day, I measured 5 volts at 50 milliamps. That's virtually nothing. That's, you could run that on a single, right through a charge pump, like I mentioned earlier, put a single AA battery on that, you could run that for a couple of days. And that's beautiful. When you're considering that people in cosplay have to wear, huge great suits, they don't want to wear huge heavy outfits and carry tons of batteries around with them. Brilliant. Basically, there's so much online for as well. They've been taken up so well by the community. It's almost impossible not to find something you want to do on it. If you want examples of how stuff has been done in the past, simply just Google, you want flashing light, Google Arduino flashing light. You want sound, Google Arduino sound. There will be someone who has done something for it. And they cost about 15 to 20 quid for an Arduino. They are cheap. They're cheap as chips. You can stack them together. You can actually have several running the same project and interlink them. I love these. If I do anything with computer control, I try to use Arduinos, just because they are so plentiful, so cheap, and so easy to use. Looks a bit more complex. It's basically a complete listing of all the pins available on a standard Arduino. All the ones with these pink tanks here, they are labeled PWM, that's pulse width modulation. That's what we were just talking about with pulse power. There are as you can see, just on a standard board, 6 pins there you can use. Each one can run a separate project for you. You want to run 6 different lights, or use those transistors we talked about here, 6 different banks of lights, all fading in independently, in and out, or running motors. They are absolutely wonderful. You also have digital inputs, and over here, these are analog inputs. So you can actually have, you don't have to do pure digital. If you want dialable values, dialable potentiometers, reading different voltages, it can do that. It can replicate whatever you put in as an analog signal and put it out as a pulse width modulated signal, which is an incredibly simple way to run a complex project. Before I go on to anything else, anyone got any questions up till now? Just because I don't want to, have people forgetting where we've got to and then not really questions later. No? Okay, fantastic. We'll move straight on. Yeah, pulse width modulation options. I think I've gone over most of it already. You can get different sizes. Well, the one I showed you back there, that's the Uno. That's the standard size, easily available, common. You've got 14 input pins on the top that you can take digital signals from. About 6 of those are analog pulse width modulation pins. You've got 6 analog pins down the bottom that you can take input signals on. But you can then get the Arduino Nano, which is about the size of a big Lego block. That's got still the 14 digital pins and the 6 pulse width modulation pins. It's also got the analog pins, but it's much more compact. There's one in the centre there, actually. They are a bit more fiddly to use, but it depends how much space you've got to play with and how confident you are soldering to smaller pins. There's also another one called the Arduino Mega, which has 50-odd digital pins, of which 20 or so are pulse width modulation pins. It allows you to control things that are absolutely humongous. The speed that the Arduino runs at, it's not massively fast compared to your desktop computer, which is probably running multiple cores at 3 gigahertz. This is only running about 16 megahertz. They made computers back in '85 that ran faster than that, but this isn't trying to run an operating system. This is literally just solving whatever puzzle you put into it. Yeah, accessories. They make tons of these things for this, and a lot of them literally slot on. If all you want to do is slot a servo pack, something I was fiddling with the other day, you've seen servos for remote control, things like that. Very high torque motors that can be moved to very precise settings. You can buy a servo pack for an Arduino. It's literally a few lines of code, and it will move anything you want, anywhere you want. If you want sensor packs, there are sensors, ultrasonic, light, heat, humidity, radio. There are some fantastic models I haven't really experimented with called the XB and Zigbee packs that actually allow you to do complete wireless control over in excess of a mile. I mean, yes, for cosplay that's kind of ridiculous, but for other things, if you get interested, you might find it fascinating. Or I don't know, good for keeping track of other people at a convention, maybe. Display modules. You can do display modules. They require a bit more wiring. You have to give up some of your pins to use a display, but they're wonderful little systems. You can have a complete readout of all the status of your motors, your LEDs, rather than just go, twist that. Is that light coming on? Yes, it is. You can actually get feedback. See what you're doing without having to have probes going into your circuitry. Development kits, sensor packages, gain controls. Have a look online. There's massive listings of this stuff. It's all controlled with a very simple programming language called processing. I'm not a very good coder, I will admit. I've tried several different languages, I'm not good at it. I think it's because I'm weak at math, but processing, which Arduino uses, beautifully simple. It's literally just run in small modules, very simple, follows one section to the next. It is quite possibly the simplest programming language I've ever run across, but it is powerful. It will let you do pretty much anything. What we've got there is basically what I'm using in that. There's a couple of tweaks, but that's all it's doing. That is just fading up those lights and taking them down again. I had hoped to be able to do a few more complex fades, but I ran out of time. So I was trying to do that 2 days before the convention started. It doesn't turn out too bad, I don't think. But as you can see, that's it, that listing. And a lot of that is actually just comments. If you removed all the comments, you'd have maybe 10 lines of code, all of which I grabbed online. As I say, you can find solutions to pretty much any problem in the Arduino forums, groups. It's all available. Instructables is a great site for hints and tips to do stuff with Arduino. It's not always high quality stuff. Some of it is just a kid's gone, I want to do something for Instructables, I'll throw something together. Just because it's not good quality doesn't mean it can't give you ideas. There's some fantastic stuff on there. Arduino.cc is the homepage for Arduino. They have some wonderful examples and reference sites. They do explain it quite well, and a lot of the reference code you can just grab straight off the page, put it in your own project, and it will work. It doesn't require a lot of interpretation. Multiplexing. Okay. I'm not entirely sure multiplexing is the correct term. I've heard different people use different terms. I think multiplexing usually refers to sending multiple signals over one line. Here we're using it for controlling multiple systems using a much smaller number of controls. As you saw, the Arduino only has 14 digital output pins with things like pulse width modulation. If you want to run more than 14 LEDs, that's a problem, because you can't turn them off. Or use something like this. There you're using, on the left-hand side, you're using 6 pins to run 9 LEDs, and they're all individually controllable. On the right, you're using 8 pins to run 4, 8, 12, 16 LEDs. Oh, we got there in the end. And again, they're all individually addressable. If you want the LED on the far right at the top, you turn one pin there on, one pin there off, everything lights up. If you're using, say, let's say you've gone absolutely crazy and you want a 200 LED dress. You want it to spell out words. You want it to be, the most glorious light-up creation anyone has ever seen. But you can't figure out how to control pins individually, all the LEDs individually. One of those Arduino Megas I mentioned, it's got 50-odd pins on it. 25 pins input, 25 pins output, set up as a grid like that, that's several hundred different pins are individually addressable. You can pick exactly which, row 9, column C, that LED I want to turn on. It makes your life so much easier. And it's not even just individual. You could have hundreds of banks of LEDs. Run those through transistors to give you enough juice. You could light an entire building, literally, run off one of those little boards just by multiplexing the outputs between 2 different grids. It's just the power goes in one way and it has to go out another way. So if you control the input and the output, you actually have 2 ways to control the component. Yeah, so X versus Y. Alright, Arduino Mega 728. There you go, I did the math in advance, so I didn't have to do it in my head. The only downside is you can only run 1 LED per pair of lines using a certain current. Obviously, if you try and run an entire line, you've then got to supply the current for that whole lot. And if you've set your resistances for your various components so that your current doesn't cook that component, you're going to be short on power for all the others. The more you run, the dimmer they're going to get. However, that pulse width modulation stuff we talked about earlier, you can run that on there as well. Increase the pulse width, use that to keep the brightness down. Is that me, or is that outside? I'm going to guess outside. You can use pulse-width modulation to actually drive hundreds of these and just keep turning up the brightness. There is a sort of a top ceiling, but then again, if you use transistors, you can run a lot of them. Let's say you wanted to run, you knew you'd have to run somewhere between 1 and 10 LEDs on a particular line, but you didn't want, you wanted the 1 to be as bright as the 10, or the 10 to be as bright as the 1. You run it through a transistor so you have enough juice, and then you use pulse-width modulation to run the 1 LED at a very low setting, say tiny little pulses every split second or whatever, and then as you increase the number of LEDs that you're turning on, you increase the pulse frequency. So more power going to the LEDs, you get increased brightness. Of course, because the Arduino's handling this, you don't have to think about it. You know, double the number of LEDs, double the pulse frequency. Works quite nicely, and it keeps things looking even. Audio, I should use a larger font for this, I apologise. You can run audio. Now, did anyone here go to Tom and Zelly's wedding last year at Kita? No? Okay, no, it's alright, I didn't think anyone would have, but they had a little box that we made that played the Mario power-up sound for them. Again, you hit the mushroom on the top, bloop, bloop, bloop. Quite funny. That used an Arduino. That just used, you can use the PCM library that's freely available online and just connect a speaker straight to it, and it will play up to a 4-second audio clip. You can go for more complex ones, but I didn't want to cover that here because it's several pages of text and code. If all you want for your costumes, I did one project for someone a while ago where I built them a little circuit that played the sonic screwdriver sound. Press the button. That was only a 4-second audio clip that was then repeated, looped, which is quite easy to do. That can all be run at 8 kilohertz in mono off an Arduino using 2 pins, push-pull. It's not great if you want, high quality speech coming out of your costume, if you want, Voldemort's head talking out the back of your own, it's going to sound a bit weird, but it's doable. You may find that sounds from those are a bit quiet. A quiet room like this, you'd have no trouble hearing it. Big party atmosphere, you might have trouble. Amplifiers, there's some very simple audio amplifiers that use transistors available out there. Google simple 1-watt transistor amplifier. I wouldn't give you the circuits here, but let's face it, if you don't have paper with you, you wouldn't be able to remember by the time you got home. You can also buy little computer speakers that come with built-in amplifiers. Hook one of those up to this, you'll have as much volume as you want. If possible, wherever possible, buy things that already do what you want, like computer speakers that have amplifiers in, or Christmas tree lights. Use them. They've already been put together, they've already been soldered, they've already been protected and joined, and you don't have to do that work. It makes your life simpler. Obviously, if you're trying to run custom stuff through an outfit, building your own has its advantages. However, there are perks to buying it in and just mashing stuff together. Tools. Coming to the end. I've gone through a bit quite quicker than I expected. You don't need an oscilloscope to do basic electronics, or even the intermediate stuff. It can be handy if you're trying to track pulses. You're generating all these pulses from this, and you've got to try and figure out, is this line working? Well, it's only on half the time, so how can you tell? This thing is a logic probe. Basically, you hook the red and the black cables up to the power supply of your project, and then you stick the little silver tip right at the end of it into whatever joint you want to test. It's got 3 little LEDs here, high, low, and pulse. If the high comes on, you've got high voltage, which is the same as your red clip. If the green comes on, you've got low voltage, same as your black clip. If the little yellow light flickers on and off, you've got pulsing signal, which is so important when you're finding bugs in your circuit. Just because you can't look at a circuit and say, oh, that's on, that's off. You have to have some way of measuring it. Logic probe is the best way to do that. Very cheap, it's a £5. Absolutely buy one, put it in your toolbox. If you're diagnosing digital electronics, you have to have one. Oscilloscopes, they're not as vital. They're very handy for digital signals just because you can actually watch the signal over time. You can see, make sure it's clean, make sure its voltages are correct, make sure you can just use it as a voltmeter. You stick it into a certain circuit, the line jumps up, you know, I've got 5 volts there, or oh, for some reason I've got 10 volts, why is that there? Multimeters, they cost, if you're lucky, you go to a car boot sale, you'll find a multimeter there for, you know, 20 quid. Might be very good, but it'll work, generally. Or you can buy a brand new one, bottom of the range is 120 quid. Bit pricey if you're only doing this as a side hobby. But you can get little things like the picoscope, which plug into your computer, turn your computer into an oscilloscope for 20, 30 quid, especially if you find them second hand. They're pretty good. The older picoscopes, they're not quite as fast to refresh, so if you're doing very high speed signals, you're not going to get a brilliant view. And we're done. I'm sorry if that wasn't as informative as anything. I'm trying to write this panel for people, and I don't know if it's coming out all right, but thank you all for coming. Has anyone got any questions?
Yeah, do you have many problems with things like skew, jitter, overshoots, etc.?
Not usually. When you're only using sort of 5 volts, things like that, you don't get a lot of overshoots, certainly, on amps and things like that. Skew, jitter, in general, when you're working with digital signals, you're using low voltages, everything tends to run very crisply, very cleanly. If you build more complex analog circuits, that's where the problems for that. Digital just tends to do what it says on the tin. So for this, I generally recommend people stay with digital. Just because when you get into analog, in a way it's almost like black magic. If you know what you're doing, yes, you can make things work, but it becomes, there's so many different, because it's not just, oh, this item has a resistance of 10 ohms. It has a resistance of 10 ohms at 3 hertz. At 20 hertz, it's got a resistance of 15 ohms. At 100 hertz, it's got... Stay clear of analog until you're, comfortable with electronics. Yes, you can do fancy stuff. It's the main reason I went with pulse width modulation for brightness and various level controls, just because it's a lot simpler to do it that way than any other. Any other questions? No? Well, thank you all very much for coming. I will answer questions if you have any. If you see me around, poke me and say anything. Otherwise, thank you.
Bravo! Bravo! Encore! Encore!